Most people at an estate sale are shopping for furniture. The rare ones are shopping for history. On a cool Saturday morning in October of 1994, the estate sale of Eudora Whitcomb opened on a quiet gravel road, just outside Story County, Iowa. With a handwritten sign that promised kitchenware, antique furniture, canning jars, and miscellaneous farm items. By 8 o'clock, pickup trucks already lined both sides of the lane as neighbors, collectors, and bargain hunters drifted from room to room carrying cardboard boxes and folding chairs, looking for something useful they could take home before someone else did. The farmhouse had belonged to the Whitcomb family since 1938, and after Eudora passed away at the age of 82, nearly everything inside was assigned a price by a local auction company that specialized in clearing old farm estates as quickly as possible. The dining table was marked at $120. The oak hutch carried a tag of $200. Even the cast iron cookstove attracted more attention than the narrow wooden cabinet standing quietly against the back wall of the pantry. It measured barely 5 feet tall and no more than 30 inches wide. Built from plain white oak darkened by decades of sunlight, with dozens of shallow drawers fitted with brass label holders, whose paper inserts had faded almost completely blank. A small sticker on the front reads simply Seed Cabinet 75. Most visitors opened one drawer, found hundreds of tiny paper envelopes inside, shrugged, and slid it closed again. They saw old seeds, brittle paper, and clutter that should probably have been thrown away years earlier. To them, the cabinet was taking up valuable space, where something more interesting might be hiding. By mid-morning, 3 different people suggested emptying the drawers and using the cabinet for hardware in a garage. Another wondered whether the wood alone might be worth more than the asking price. Nobody stopped long enough to read the handwriting covering the envelopes, because nobody believed there could be anything worth reading. Nobody except one man. Let me tell you about the moment Thaddeus Wren walked through that pantry doorway. Because that quiet moment is the reason this story exists. He did not look at the cabinet first. He looked at one yellowed envelope that someone had left half open on the edge of a drawer. He leaned closer without touching it. Then he noticed a tiny notation written in brown fountain pen, ink along the lower corner. 4 words, barely larger than a thumbnail, caused him to stop breathing for just a second. Because they should not have existed together on the same envelope. In the decades before seed companies filled glossy catalogs with uniform hybrids and nationwide distribution networks, the future of American agriculture often rested inside ordinary farmhouses. Every county had families who quietly selected, dried, labeled, and stored seeds from the strongest plants each harvest. Not because anyone instructed them to do so, but because that was simply how farming survived uncertain seasons. A successful tomato was not merely planted, it was remembered. A dependable bean was not purchased every spring. It was passed from one generation to the next with careful notes about rainfall, frost dates, soil conditions, and the field where it had performed best. This was not a hobby. It was a living record of adaptation. Let me tell you about the world those envelopes came from, because you need to understand why one small handwritten note could stop an experienced plant breeder in his tracks. Before commercial breeding narrowed countless crops toward uniform appearance and predictable shipping qualities, farms across the Midwest relied on locally adapted varieties that slowly evolved alongside the land itself. Corn selected on a windy ridge became different from corn grown beside a river. Squash planted for 30 consecutive summers in heavy black soil gradually favored characteristics that no laboratory intentionally designed. Farmers rarely described this process with scientific language, yet year after year, they were shaping genetics through observation, patience, and repetition. Every harvest became another quiet experiment. Every successful plant earned another season. Every disappointing one disappeared forever. The cabinets that stored these collections were built for order, rather than beauty. Shallow drawers protected paper packets from crushing. Thick wood buffered sudden temperature changes. Brass label holders allowed names, years, and field locations to be updated without replacing the drawer itself. Some families organized by crop, others organized by season or by the person who originally supplied the seed. Moisture mattered. Excess heat mattered. Even the kind of paper surrounding each collection mattered, because trapped humidity could reduce germination long before anyone noticed visible damage. Experienced growers understood these details without calling them preservation science. They simply called it taking care of next year. By the early 1990s, however, many of those cabinets had disappeared from American farmhouses. Younger generations purchased fresh seed every season. County seed exchanges became smaller. Local breeding traditions quietly faded as commercial varieties offered convenience and consistency. To most people, an old drawer filled with handwritten envelopes represented outdated habits that modern agriculture had already replaced. To someone who understood plant breeding, it represented something entirely different. It represented decades of selection decisions that could never be recreated once they were thrown away. And standing silently before those weathered drawers, Thaddeus Wren had already begun to suspect that he was looking at a collection assembled by someone who understood far more about seeds than anyone at that sale had realized. Let me tell you about Eudora Whitcomb, because the cabinet only makes sense once you understand the woman who spent nearly 6 decades filling it one envelope at a time. Eudora was born in 1912 on a small diversified farm outside Nevada, Iowa, where livestock, vegetables, oats, corn, and orchard trees shared the same acreage, because that was how family farms survived before specialization became the rule instead of the exception. Her father, Silas Whitcomb, believed that every harvest deserved to teach the next one something new. And from the time Eudora could read his careful handwriting, she followed him through fields carrying a small canvas bag, while he pointed toward the healthiest plants, instead of the biggest ones. He never selected seed from the earliest ear of corn, or the largest pumpkin simply because it looked impressive. He watched which plants endured late frost, recovered after dry weeks, resisted insects without unusual damage, and produced consistently despite unpredictable weather. He believed that reliability was more valuable than perfection. And Eudora accepted that lesson long before she understood the science behind it. After marrying Daniel Whitcomb in 1938, she continued the same habit on their own farm, without announcing it as anything special. Every autumn she spread cleaned seeds across fine wire screens, inside an upstairs room where afternoon sunlight never reached directly. She waited until moisture had fallen naturally, before placing each collection into paper packets that she folded by hand instead of sealing with glue, because folded paper breathe during long storage. Each envelope received more than a crop name. She recorded the field location, the growing season, unusual weather, pollination observations, flavor, storage quality, and sometimes a short sentence that only she would fully understand years later. Her notes became longer as time passed, because experience taught her that memory fades faster than ink. Neighbors occasionally traded seed with her after county fairs or church suppers, and she accepted every exchange with quiet curiosity, rather than excitement. She rarely claimed that one variety was superior to another. Instead, she wanted to know why it performed differently under different conditions. That question shaped the rhythm of her entire life. By the 1970s, while many nearby farms depended almost entirely on commercially purchased seed, Eudora still walked her fields every evening during late summer, carrying a notebook and a pencil sharpened with the same pocket knife she had owned for decades. Most people assumed she was simply reluctant to change. They never realized she was building one of the most detailed private selection records in the county. one careful season after another, and the meaning of those quiet observations was still waiting inside drawers that almost everyone had already dismissed. Let me tell you about Thaddeus Wren, because he was not the kind of plant breeder who searched for perfect crops. He searched for forgotten decisions. Thaddeus was 56 years old in the autumn of 1994 and had spent more than 3 decades studying open-pollinated varieties across the Midwest. He lived outside Decorah, Iowa, where rolling hills and smaller family farms had preserved older agricultural traditions longer than many larger grain-producing regions. His father, Alaric Wren, had never earned a university degree, but he understood something that shaped his son's entire career. He believed every seed carried 2 stories at the same time. One story belonged to biology. The other belonged to the farmer who chose to save it. As a boy, Thaddeus spent countless Saturdays driving with his father from one farm to another, not buying machinery or livestock, but sitting at kitchen tables while elderly growers emptied coffee cans, cigar boxes, and glass jars filled with seeds that had remained in their families for generations. Alaric rarely asked whether a variety produced the highest yield. Instead, he asked where it came from, how long the family had grown it, what weather it survived, and why the farmer had continued selecting it instead of replacing it. Those conversations became Thaddeus's first classroom. Years later, he studied plant genetics at Iowa State University, where professors explained inheritance patterns, population diversity, natural selection, and pollination biology with charts and laboratory data. He respected every lesson they taught, yet he never forgot what his father had shown him first. Science explained how traits move through generations. Farmers explained why they chose those traits in the first place. Throughout his career, he traveled thousands of miles each year visiting remote farms, county historical societies, church festivals, and small agricultural museums, documenting local varieties before they quietly disappeared. He carried a leather notebook filled with names, growing locations, planting dates, and family histories, because he believed that removing a seed from its story reduced half of its value. Colleagues occasionally joked that he spent more time talking with retired farmers than working inside research greenhouses. He accepted the criticism without argument, because he had already learned that some knowledge never appeared in scientific journals. It survived only through ordinary people who remembered ordinary details. Standing inside that quiet farmhouse, Thaddeus did not see a collection of aging packets. He saw decades of disciplined observation organized by someone who understood patterns rather than trends. Then his eyes returned to the tiny handwritten notation that had caught his attention only moments before. The wording did not match any breeding record he had ever encountered, and for the first time in many years, he found himself wondering whether someone he had never met had quietly solved a question that modern plant breeders were still trying to answer. Let me tell you why that single handwritten notation mattered, because the answer begins long before a seed ever reaches the soil. Every plant breeder understands that the greatest value inside a seed is rarely visible from the outside. 2 kernels of corn can appear identical in size, color, and weight while carrying entirely different combinations of inherited traits. One may tolerate prolonged drought, another may resist fungal disease, a third may mature several days earlier, avoiding the first autumn frost by the narrowest margin. Those differences are not accidents. They are the result of repeated selection over many growing seasons. Each year, a careful grower chooses only a small percentage of plants to become the next generation. That decision slowly shifts the genetic makeup of the population, strengthening desirable characteristics, while allowing weaker ones to disappear naturally. Plant breeders call this directional selection, but families like the Whitcombs simply called it paying attention. Equally important was the information written beside each collection. A variety without records is only a possibility, A variety accompanied by decades of observations becomes evidence: weather conditions, planting dates, harvest timing, soil texture, pollination distance, storage performance, insect pressure, and flavor all provide context that transforms seed into knowledge. Without those notes, future growers would know what they possessed, but not why it had succeeded. Moisture control also determined whether a collection remained alive. Most agricultural seed stores best when internal moisture remains low enough to slow biological activity without damaging living tissue. Excess humidity allows fungi to develop. Excessive heat accelerates natural aging. Proper air circulation and stable temperatures preserve germination far longer than sealed containers exposed to changing conditions. Even the choice of ordinary paper instead of plastic served a purpose, because paper allowed small amounts of moisture to escape, rather than becoming trapped around the seed. Isolation during flowering mattered just as much. Corn releases pollen that can travel remarkable distances on the wind. Squash often depends on insects carrying pollen from blossom to blossom. Beans usually fertilize themselves before flowers fully open. Every crop demands different management if a grower wishes to preserve a stable variety year after year. That is why experienced seed keepers separated plantings, timed flowering periods, or selected individual plants with extraordinary care. None of these practices appeared dramatic while they were happening. They looked like ordinary farm work repeated season after season. Yet together they created something far more valuable than a simple collection. They created a documented record of adaptation across changing weather, changing soils, and changing generations. As Thaddeus studied the faded handwriting more closely, he realized the unusual notation was not describing the seed itself. It was describing the breeding decision that had produced it. And that distinction changed everything he believed he was looking at. Thaddeus did not reach for his wallet. He reached for the first drawer. That choice alone separated him from everyone else in the room. Most buyers evaluated objects by condition. He evaluated them by sequence. He slid the drawer open only a few inches, and immediately noticed that the envelopes were not arranged alphabetically. By crop, or by year, they followed a pattern that revealed itself only after several minutes of careful observation. The first section contained field corn collected over nearly 30 growing seasons. Behind those were dry beans, each packet carrying dates that advanced in steady order, rather than scattered randomly. Farther back came tomatoes, squash, cucumbers, peppers, and several root crops. Each group divided by handwritten symbols, instead of commercial names. It was not the organization of a collector. It was the organization of someone conducting a lifetime of experiments. Let me tell you about what Thaddeus saw next, because every drawer quietly changed the story. One envelope contained only a few kernels with the words, "Third selection after windstorm," followed by a harvest year from the early 1960s. Another carried a note explaining that the parent plants remained standing after neighboring rows had lodged during severe summer storms. A packet of pole beans mentioned unusually cool nights before flowering. A squash entry recorded that only 3 vines had produced healthy fruit after extended rainfall. None of these observations sounded dramatic by themselves. Together they formed a continuous record of deliberate selection across changing environmental conditions. Thaddeus realized that Eudora had never been preserving individual varieties alone. She had been documenting the reasons each generation deserved to continue. As he continued moving from drawer to drawer, the handwriting itself changed with time. Earlier entries were short and practical, later ones became increasingly detailed, describing pollination timing, flowering intervals, seed maturity, storage performance, and comparisons with previous harvests. Some envelopes referred to observations made 15 or even 20 years earlier, showing that she routinely revisited old breeding decisions instead of treating each season as an isolated event. That kind of continuity was extraordinarily uncommon outside formal research programs. Around him, visitors continued carrying away lamps, dishes, quilts, and furniture without paying attention to the quiet discovery unfolding only a few feet away. One man briefly asked whether the cabinet was still available, glanced inside a partially open drawer, smiled politely, and walked away without another word. Thaddeus barely noticed. His attention had settled on the lowest drawer, where a narrow row of plain brown envelopes carried no crop names at all. Instead, each one displayed a coded combination of letters and numbers followed by short handwritten remarks that looked less like inventory labels and more like private research notes. The same unfamiliar notation appeared again, repeated with remarkable consistency. And he suddenly understood that whatever Eudora had been doing during the final years of her work had never been intended for casual observers to recognize. Thaddeus carefully lifted the first coded envelope from the drawer and turned it over without opening it. The paper itself told part of the story. It was heavier than the others, folded with unusual precision, and marked by years of careful handling, rather than neglect. Across the front appeared a sequence, unlike any accession number used by the United States Department of Agriculture, any university breeding program, or any commercial seed company he had ever studied. Beneath the code, written in the same steady fountain pen, were 5 simple words. Observe the offspring. Never the parent. Thaddeus read the sentence twice, then a third time. Let me tell you why those words mattered, because almost every breeding program of the 20th century focused first on selecting outstanding individual plants. Those plants became the parents of future generations. Eudora had written the exact opposite. She was reminding herself that the true measure of a breeding decision did not appear until the following generation revealed which characteristics remained stable, and which quietly disappeared. It was a remarkably disciplined philosophy, one that experienced breeders eventually learned, but rarely reduced to a single sentence. He opened another coded envelope. Inside were only a handful of carefully preserved bean seeds accompanied by a narrow slip of paper, listing planting distances, flowering dates, weather observations, and one final remark, stable after 7 generations. His pulse quickened. 7 consecutive generations of documented selection required years of uninterrupted work. The next packet described a squash population that had been intentionally exposed to unusually wet growing conditions before seed was collected. Another referred to repeated dry summers and selection, based only on fruit set rather than plant size. None of the coded collections sought perfection in appearance. Every one of them rewarded consistency under difficult conditions. Thaddeus suddenly understood that Eudora had not been preserving heirloom varieties in the traditional sense. She had been quietly developing resilient breeding populations, while documenting every decision with extraordinary discipline. He removed a small notebook from his coat pocket and copied several of the codes, exactly as they appeared. Then he compared them with references he carried for regional breeding lines. Nothing matched. Not one code appeared in his records, not one notation resembled university archives he had visited across Iowa, Minnesota, Wisconsin, or Illinois. Around him the sale continued exactly as before. Folding tables became emptier. Conversations drifted through the hallway. Someone carried away an antique rocking chair. Another buyer negotiated over glass canning jars. Nobody noticed that one quiet corner of the farmhouse had become the center of an entirely different discovery. Thaddeus slowly closed the drawer, realizing he was no longer asking whether the cabinet was worth $75. He was asking whether anyone besides Eudora had ever known these breeding records existed. Because if the answer was no, then the greatest agricultural inheritance inside that farmhouse had remained hidden in plain sight for decades. Thaddeus purchased the cabinet without negotiation, loaded it carefully into the back of his pickup, and drove north before the afternoon light began to fade across central Iowa. He did not open another drawer until the cabinet stood inside the climate-controlled workroom behind his small breeding facility, near Decorah. There, every envelope was photographed, cataloged, and compared against reference collections that he had assembled over more than 30 years. Let me tell you what happened over the following months, because this was the point where careful observation replaced first impressions. Several seed samples still possessed surprisingly strong germination despite their age. Others produced only a handful of healthy seedlings, yet even those survivors revealed something unexpected. Plants from different envelopes shared uncommon combinations of characteristics that rarely appeared together in commercial breeding material. Some matured consistently within remarkably narrow harvest windows. Others demonstrated unusually stable performance despite noticeable changes in spring rainfall. A dry bean population expressed exceptional uniformity after generations of documented family selection, while a squash line maintained vigor across multiple trial plots, without the decline breeders often expected from small privately maintained populations. None of these findings proved that Eudora had created revolutionary new varieties. They demonstrated something equally important. Her written observations matched measurable field performance with extraordinary consistency. Thaddeus contacted colleagues at Iowa State University, the Seed Savers Exchange near Decorah, and several independent researchers who specialized in heirloom crop preservation. Rather than making dramatic claims, he invited them to review the records themselves. The reaction remained remarkably consistent. Experienced breeders spent less time discussing the seeds than they did studying the notebooks and envelope annotations. They recognized decades of disciplined selection conducted according to repeatable principles rather than chance. One genetic resources specialist quietly remarked that very few private collections documented breeding decisions with this level of continuity across so many growing seasons. Another researcher observed that Eudora had unintentionally created a historical record, showing how one careful grower responded to changing weather patterns over nearly half a century. Copies of selected notes were preserved for future study. Several living populations entered long-term conservation plantings, so they could continue being evaluated without losing the connection to their documented history. The cabinet itself remained exactly as Eudora had organized it, including every drawer, divider, handwritten label, and folded packet. Thaddeus refused suggestions to reorganize the collection into a more modern filing system, because he believed the arrangement represented part of the evidence. The sequence of the drawers reflected the sequence of her thinking. Years after that quiet Saturday morning, visitors occasionally asked him which envelope contained the greatest treasure. He always gave the same answer. It was never a single envelope. It was the relationship between every envelope, every note, every growing season, and every careful decision recorded by a woman who understood that preserving knowledge required far more patience than preserving seeds. Years later, when young plant breeders visited Thaddeus Wren's workroom, they expected him to begin with discussions about genetics, pollination, or field trials. Instead, he always led them to the same wooden cabinet and asked them to spend 5 quiet minutes reading the handwriting before asking a single scientific question. Most of them noticed the dates first. Some noticed the careful organization. A few recognized the remarkable consistency of the observations. Eventually, someone always asked the same question. Why would one person spend so much of her life recording details that almost nobody else would ever read? Thaddeus always smiled before answering, because he believed the cabinet itself already contained the explanation. Let me tell you what Eudora Whitcomb actually preserved, because it was never only about seeds. Every folded packet represented a decision made after watching an entire growing season unfold. Every notation reflected patience instead of urgency, every correction, every comparison, every weather observation, and every carefully selected parent plant formed part of a conversation between one farmer and the land. She worked for more than half a century. Those conversations could not be purchased from a catalog. They could not be recreated inside a laboratory after the records disappeared. Once forgotten, they were gone forever. The greatest lesson hidden inside that cabinet was not that old methods were better than modern science. It was that careful observation gave modern science something valuable to study. Research explained patterns. Experience revealed where those patterns first appeared. Together they created understanding that neither could achieve alone. The cabinet remained exactly where Eudora had left it. Its drawers opened in the same sequence she had followed for decades. Because changing that order would erase part of the story she had quietly written through ordinary seasons of ordinary work. Visitors often stood before it expecting to find a famous variety, or an extraordinary discovery waiting inside one particular envelope. Instead, they found something less dramatic and far more enduring. They found evidence that knowledge grows the same way healthy crops do, one careful season at a time. The $75 price tag had disappeared long ago, replaced by a simple card carrying Eudora Whitcomb's name, and the years she devoted to preserving what others never realized they were losing. Thaddeus never described the cabinet as priceless, because every object can be assigned a number. He simply said that some things become impossible to value once you understand what they truly contain. Long after the farmhouse was sold, the furniture scattered, and the ordinary belongings found new owners. One quiet collection continued teaching farmers, researchers, and students that history does not always survive inside museums. Sometimes it survives inside the patient handwriting of someone who believed the next generation deserved to inherit not only better seeds, but better reasons for choosing them.